Today we're going to look at the sum and difference identities for sine and cosine. Now if you've watched the video on sin, and coset, then you already have a bit of clue to how these formulas work out. I'm going to reference that video several times in this, so if you haven't watched it yet, it's not very long. It just tells you a story about how you can memorize these formulas with really not ever technically memorizing them. If you just know the story, then you're going to know how to write these formulas down. They're really similar, and so it's really easy to get them mixed up. And so it's a nice thing to have so that you can make sure that you don't make any kind of careless mistakes when trying to work these out just in practice. Okay, so the sum and difference identities are essentially a formula where I have the ability to add two angles that I know or subtract two angles that I know from the unit circle that will add up to some other angle that I don't really have a lot of information about. For example, let's look at the first one. Sine of a plus b. In this case, when the story talks about Sinbad setting up the date, then it's talking about using sine of a plus b or sine of a minus b. When he sets the date up, he always sets it up this way. Sinbad sits up front with coset, right? And he says their signs are the same, right? And the signs I'm referring to would be the signs here and here, these two different signs there. And then in the back sits her sister and his brother, right? So we'd say cosine of A and sine of B. I tend to keep the A and the B in the same place, so A comes first, B comes second, A first, B second. So I swap the trig functions. Really, it doesn't matter which way these are being multiplied together because we can multiply in any order. If we do it the other way around, we'll say it's sine A cosine B, right? He sits up front with coset, and the signs are the same. Since I'm subtracting this time, it'll be subtraction here, and then cosine A sine B. Now we switch gears a little bit, and we're going to go to cosine, or coset setting up the date. She says, I don't think so. I'm going to sit with my sister. So cosine A, cosine B, right? So coset is sitting up front with her sister here, and she says we are nothing alike. Our signs are different, and so Sinbad sits in the back with his brother. We have sine A, sine B here. And the same thing with the cosine A minus B, cosine A, cosine B. Here again, we're going to swap the signs, sine A, sine B. Now, do you need to know the story? No, but it does make things a lot easier when I'm writing this out. I can remember the story rather than remembering kind of seemingly just a combination of sines and cosines. That can get fairly complicated, especially when they're so alike. Okay, so let me do an example for you, and that's going to be pretty much it for the notes today. There's not a lot of extra twists and turns here. In this example, I'm going to give you an angle like the sine of 105 degrees. Now, there are a few things that I have to remember. Number one, when we're working with an angle, this angle that you're going to be given is not going to be an angle that you're familiar with. When I say familiar, I'm referring to the unit circle. Yes, the unit circle is back. The rule is, right, number one, you have to choose an angle that combines, or choose angles that combine to get the angle that you have up in here, but they have to be from the unit circle. Right, now I can add them or I can subtract them. It does not matter, but we have to choose angles from the circle that combine to give you whatever the angle is here, right? And so in step two, we're going to basically plug it in, right, to my formula. In this example, I think I'm going to use, let's say 45 plus 60. Two angles from the unit circle, and if we're being really clear, when I'm referring to this, I mean a multiple of 30 or 45, right? So 30, 60, 90 would work, but you probably will never choose 90, 120, all of those things. If you go all the way around the unit circle, if you're using any angle from the unit circle, you're in good shape, okay? So how does it work into the formula? Let's do it like this. I'm using sine, and I'm adding two angles, right? So we're going to be working with sine of A plus B, right? So sine of 45 plus 60. This was serving as my A. This is my B. If you had done 60 plus 45, that would be fine too, because it doesn't matter which order we multiply or we add in, so it's going to work out. And I'm really just going to plug it into the formula above. So we're going to say sine of 45, cosine of 60. That's going to be plus, because the signs are the same, cosine 45 and sine of 60. If you ever get down to it and you've done something where you got the same thing in the front part and the back part of the formula, you know you've kind of messed up somewhere. At this stage, the third section is to just evaluate what you have. And that's going to mean that I'm going to have to go back to the unit circle. I can draw the triangle. I can use my left-hand rule. I'm going to draw the triangles out for you here. Now, if I'm drawing 45, then I'm going to draw 45. If I have 135, then I'm going to draw that in the second quadrant, because that means that one of my sides is negative. And in this example, that's really important. I have to keep that consistent. If I'm drawing an angle that's not in the right place, then I'm going to lose a sign, and that will mean that I'll get the problem wrong. So that's not 45, that's 60. So we draw 60 here, that means that one would be 30, so this would be 1, I square root of 3, and 2. Super important here, because if I've got these triangles drawn, these two triangles here and here, I pretty much have an easy way to get all these values, because we know SOHCAHTOA, sine is opposite over hypotenuse, or cosine is going to be adjacent over hypotenuse. I'm going to come down and I'm going to plug all these values in and simplify, and that's pretty much all you're going to have to worry about. So when I evaluate this, sine of 45 is the square root of 2 over 2. Now I know that if you come up here and you do the sine using my sides, I'm not going to get exactly that. I'm going to get 1 over the square root of 2, but remember, I'll tell you, just making things easier, I'm going to rationalize, and I'm going to just use the square root of 2 over 2 as that value. It's going to make my fraction easier to work with. I'm already going to have a common denominator. Not to mention, we've done that a bunch, and sine of 45 or cosine of 45 always ends up being square root of 2 over 2. A lot of us, you already knew that, and that's definitely a positive thing. Okay, so cosine of 60, so I'm going to come over to 60. Cosine is going to be 1 over 2. That's going to be 1/2, or if you use your left-hand rule, you would know that. Plus cosine of 45, I'm not even going to look it up because I know what it is. It's square root of 2 over 2. Sine of 60 is going to be the square root of 3 over 2. And I can look those up in the triangle, or I can use my left hand to kind of work that out. If you don't remember the left-hand rule, go back and look that up. Here, radicals do multiply. So when you multiply fractions, remember you're going to multiply the tops of the fractions and the bottoms of the fractions together. I already noticed that I'm going to get a 4 on this side and a 4 on that side. So I'm going to go ahead and write this as one large fraction. It's already got a common denominator. When you add fractions with common denominators, you always add their top parts together and you keep the denominator the same. The rule is when you multiply radicals, as long as it's both square roots, I can multiply the numbers under the radicals. So 2 times 3 would be 6. The square root of 2 times 1 obviously is just going to be the square root of 2. So we're going to end up with the square root of 2 plus the square root of 6. Now if you'd done it backwards, maybe you did 60 plus 45, you would have ended up with square root of 6 plus the square root of 2 over 4. And because we can add in any order, it doesn't really matter. However, some people may want to reduce here. That would be an incorrect step. You cannot reduce. This looks like it's 2, but it's the square root of 2. That's not even a whole number. It's 1.41 something, right? So because you have an even set of values here, because they're under the radical, you cannot reduce. This is the answer, and that is in simplest terms. Okay, and that's pretty much all you have to know in terms of how to use these formulas, right? Really what we want to know is, number one, I have to choose the right setup. I'm going to tell you based on the problem whether it's sine or cosine, so that's not a choice. But whether you add numbers together or subtract them, That's going to be up to you. I could have chosen 150 minus 45, and that would have been a subtraction problem, right? That's still unit circle numbers, and I could have gone to the sign of a minus b and worked it out that way. It doesn't matter. You'll have to choose that when you get to it and go through it from that way. So that's it. That's all there is to using the sum and difference identities in terms of evaluating them. You're going to plug the values in from the unit circle like you have here. Make sure if you use an angle outside the first quadrant, make sure you draw it in the right quadrant, or make sure to remember your left hand if you're using it to add the negative signs that make it appropriate. And that's all we have for today. If you got questions, let me know, shoot me an email, and I'll get back to you as soon as I can.